Today we're going to be looking at diffraction of wave. So what you need to know about diffraction of wave is firstly its definition, and then the effects that it have towards frequency, speed, and so on, and then the different situation. But this video will mainly focus on water waves, okay? Because I will do a separate video in terms of sound and light, right? So first off is the definition of diffraction. So the definition of diffraction, the key word that is often used for the definition is the spreading of wave. So it happens, the wave will spread out when there are two things that happen, when they meet two things. Number one is either an obstacle or an opening, or we call it an aperture. Okay, so how it affects frequency, speed, shape, wavelength, and direction. Okay, so there are a few that doesn't change and there are a few others that change. So the frequency of the wave after a diffraction happen or after passing through an aperture or an obstacle is not changed. It's going to remain constant. And because frequency doesn't change, so speed doesn't change as well, and so is wavelength. So all of it will remain constant. And the only two things that changes is the direction and also the shape of the wave. So the wave will take a different shape, and also the direction will be more spread out. Some are spread out like this and some are spread out like this. So it depends on the aperture or the obstacle. Okay, so for water wave, the different situation that you can have in an experiment is either changing the size of the wavelength. So that's basically just changing the frequency of the dipper in the ripple tank. So if you make the frequency higher or you make the frequency lower, then you will change the size of the wavelength, and you can check and see how the diffraction pattern changes as it passes through the obstacle or pass through the aperture. Okay, so for different size of wavelength, as the wavelength is longer, then the effects of the diffraction will be more obvious. Means the shape will look more obvious, like it is diffracted or spread out. So this is how you're going to answer the question in SPM. Like if they ask you what is the effect of diffraction, you either say the diffraction pattern is more obvious or less obvious, okay, when you have to make comparison. All right. Second situation will be in terms of a different size of the aperture or the obstacle. So if you make the opening bigger or the opening smaller, or the rocks or the things that you put in the ripple tank, if it's a smaller size or a bigger size, how will it affect diffraction? Okay, so let's say the smaller size. Okay, so the smaller the opening, the smaller the aperture, or the smaller the obstacle, then the effects of the diffraction will be more obvious. Means you can see the spreading out of the wave even more. So now we're going to look at how we are going to draw this diffraction pattern. So first off, you need to know whether they are more obvious or less obvious. So in this case here, for a fixed size of aperture but a different size of wavelength, so you've got shorter wavelength and you've got longer wavelength. So the effects of diffraction will be obvious in the in the longer wavelength and less obvious in the shorter wavelength. So you do first is you draw the direction that is spread out. So the direction for the longer wavelength have to be more spread out, and the direction for the shorter wavelength should be less spread out. So let's draw that and see. So the direction of the spreading out of the wave will look something like that. And now to draw the wavelength that comes out, you have to make it seem like it curved a little, but making sure that the wavelength doesn't change. 3 is enough. And for the longer wavelength, so the curved shape is more obvious for longer wavelength and less obvious for shorter wavelength. Okay, so this one here is for obstacle and also aperture. So you got a large aperture, the first one, the second one is small, and then the third one is a larger obstacle, and the last one is a smaller obstacle. So first we're going to look at the one with the larger aperture first. So large aperture means less obvious, and small aperture mean more obvious. So let's draw the direction line that is going to spread out. Okay, so let's say that the direction looks like that. So now what you do next is just draw the wavefront, but making sure that the wavelength is the same size. 3 is enough. Okay, so now we're looking at obstacle. So obstacle, the direction that is spread out will be different, and large obstacle will be less spread out, and smaller obstacle will be more spread out. So let's draw the direction line. Okay, there you go, the direction of it spreading out. Now we're gonna have to draw the diffraction pattern. Okay, so for this one, there will be no wave at the middle part of where the obstacle is. So the wave that you need to draw will be up here. So when you draw for a less obvious one, make sure that the curve is just a small curve. And for the more obvious one, obviously the bigger the curve. Right, there you go. That's the drawing for the diffraction of water waves. So now we're going to look at an application of a diffraction of water wave. So if you see here in this picture, this is what we call water breaks. So this rocky structure are purposely made to make diffraction happen. This is so that when waves come from the sea, if the wave is like too big and contain high energy, right, high amplitude, so when they come here, they become spread out, then they will carry less energy. So the people over here can enjoy the sea and the beach peacefully. Okay, so aside from this, and this is another sample of water breaks, some of them are made to be like this. So if you have a beach area, sometimes you just have like multiple rocks being placed all together there. So that will be the water breaks to avoid you from catching a huge wave that comes towards you. So lucky you, and now you're safe. The last thing that we're going to be looking at today is a sample SPM question. This is from paper 2 section A. So they give you picture, diagram 3.1 and 3.2, and then there are a few questions over here. So what you can do is you can pause the video, try out the question, and come back later for the answer. Okay, so let's look at this question. All right, so you've got two water waves. So the thing that you can notice here is the wavelength. So this is shorter wavelength, and here is longer wavelength. So more obvious and less obvious. Okay, so question A is what is meant by wavelength. So this one you should know already what is the meaning of wavelength. So there are multiple ways to write it, but usually the most accepted one will be the distance between two successive crests, or the distance between two successive troughs. And second question, based on diagram 3.1 and 3.2, you have to write down the observation. So this is more in terms of like the effects of diffraction, like what does diffraction do, what does it change. So first thing that you can see when a diffraction happens, the thing that changes here is the shape of the wave. So shape of the wave after passing through the gap. And I'm using the word gap here because that is what is used in the question. But if you use slit or aperture or opening, it's still correct. Okay. And then the second observation is also in terms of the effects of diffraction. So you know the things that change when diffraction happens. So you can talk about something that doesn't change. But mostly when it comes to observation, it must be something that you can see directly from the picture. Not what you know, but what you see. Okay, so what you see here is the shape, and you also can see the wavelength. You don't see the frequency, you don't see the speed. So your observation should be in terms of the wavelength and the shape. So in this case, the wavelength doesn't change after it after a diffraction happened. Okay, now C is where they tell you to compare between the two. For B just now is just an observation of an experiment, okay? So now when you compare, this is where you talked about which one have a more obvious pattern of diffraction. So obviously, okay, so there are some more questions here. You can pause the video, try out, and also come back later for the answer for E and F. So to solve D, okay, the relationship between the wavelength and the wave pattern. So the longer the wavelength, as you can see in the picture here, so longer wavelength means a more obvious diffraction pattern. So that should be your answer in terms of relationship. Okay, the wave phenomenon here is of course diffraction of wave. Diffraction is the keyword. Okay, and then the last one, what is the characteristic of the wave before and after? So you know that wavelength, frequency, and speed doesn't change. So all of these are the same. Well, the amplitude represent the energy of the wave. So you must remember that after a diffraction happened, the energy is lower. So amplitude means will also be lower. So before it was high and after it was low. Okay, so summary for today's lesson. We've looked at the diffraction of water wave. So you've seen what caused it. Two things that caused it. The first one, if it has an aperture, it has to pass through an aperture. And then the second one is if it has to pass through an obstacle. And then the second one, we've also looked at the effects of it. So the thing that changes is direction, because it becomes more spread out, and the shape, because it becomes more curved, and also the energy or the amplitude. So it will become lower. And then the thing that doesn't change, wavelength, frequency, and speed. Okay. And then you've also looked at applications of water diffraction. And you've also learned how to draw the diffraction pattern. Okay, so that's all for today's video. Thank you for watching.